Welcome back to AI.Code.Cast. Today, we're going on a deep dive into something that might seem pretty basic at first glance,
Yeah.
but it's got some really interesting stuff going on under the hood. We're talking about simplifying file paths.
Oh, yeah. File paths, they can be a real mess.
Exactly. Like, you've got all these long paths with a ton of slashes and dots, and it's like,
Totally.
how do we clean this up? How do we make it so a computer can understand these things?
Yeah.
And for us as programmers, like, how do we even begin to tackle this?
Well, I think it's helpful to think about what's actually going on when we use file paths. Like, imagine you're actually navigating through folders on your computer.
Yeah.
Like you're clicking through different directories and you're going deeper and deeper into the file system.
Yeah.
Sometimes you got to go back up a level or two. It's like that's what we're trying to replicate with code, right?
Absolutely. And like you said, sometimes you have to go back up a level. That's where
Yeah.
those come in, right?
Right, exactly. The day means go up one directory, and then you got the A, which means just stay put.
Right, right. So it's like we need some way to keep track of where we are in this
Absolutely.
hierarchy of folders, this tree structure.
Exactly. That's a great way to put it, a tree structure. And when I think about trees, I think about stacks.
Ooh, stacks. Now we're talking. So how could a stack help us with simplifying file paths? I mean, they're all about that last in, first out thing, right?
Yeah, exactly. And think about it this way. Pushing onto the stack is like going into a subdirectory, right?
Yeah.
And popping something off the stack is like going back up a level.
Oh, I see. So like if we have a path like home use documents, we
Yeah.
push home onto the stack first, then user, and then document.
Yeah, exactly. And each time we push something onto the stack, it's like we're moving deeper into the file system.
Got it. But what about those pesky components? How do those fit into the picture?
Well, when you encounter a data, it's like saying, okay, I need to backtrack. And with a stack, backing up is as simple as popping off the top element, just like going back up one directory.
So we'd pop documents off the stack, leaving us with home and user, which is exactly where we'd be if we actually went up one level in the file system.
Right. You see, it's like the stack perfectly mirrors our movements through the file system.
This is blowing my mind. I'm starting to see how elegant this solution is.
Right. And don't forget about those components. Those are the easiest of all.
What do we do with those?
We just ignore them, like they're not even there.
Okay, so we push directory names onto the stack, we pop when we hit a right, and we completely ignore it's like a dance.
Exactly, a perfectly choreographed file path dance.
So now that we have a general idea of how this stack-based approach works, how about we dive into a concrete example to really see it in action?
Sounds good to me. Let's do it. Okay, so let's take that messy path example we mentioned earlier. You know that home user documents.pictures?
Yeah, that one's got it all right, like double slashes and single dots, and
Yeah.
it's like a real-world path, what we actually see in the wild.
Exactly. And to make sure we're all on the same page, we're starting with an empty stack.
Right, empty stack. That's our starting point.
Yeah.
Okay, so first up, we've got home.
All right, so we push home onto the stack. So far, so good.
Okay, home is on the stack.
Mm-hmm.
Now we hit that empty component,
Yeah.
from the double slash.
Right, right. And remember what we said about those empty components and they're basically no ops. They don't change our position in the file system.
Yeah, they're like those little detours that don't actually take you anywhere.
Exactly. So we can just skip right over that empty component, and then what do we have? User, right?
Right, user.
Yeah.
So we push that onto the stack.
On top of home. So now our stack represents our current position. We're in the user directory within the home directory.
Makes sense.
Yeah.
Okay, so next up, we've got
We know what to do with those.
ignore them, like they never existed. Easy enough.
Mm-hmm.
And then we've got documents, so we push that on the stack as well.
All right, so we're getting deeper into the file system. Our stack is growing.
Okay, and then, oh boy, here comes what do we do now?
This is where the stack really shines, right? Because live means go up one level, and with the stack, going up means popping. So we pop documents off the stack.
So we're basically undoing our last move, right? Like we went into the documents directory and now we're backing out.
Exactly, we're backtracking. And now our stack has home on the bottom and user on top, just like where we'd be in the file system.
Got it. And finally, we have pictures.
And pictures is just a regular directory name, so we push it onto the stack right on top of user.
Okay, so now our stack has home on the bottom, then user, and then pictures at the top. I think we're done right.
We are. We've reached the end of our path, and now all we need to do is take those elements from our stack and string them together to build our simplified path.
Okay, so starting from the bottom of the stack, we have home, then user, then pictures. So that gives us home to pictures. It worked.
It did. We took that messy, confusing path, and with the help of our trusty stack, we turned it into a clean, simplified form.
I am so impressed. That was so smooth and it makes perfect sense. But I'm also thinking, there are always those edge cases. What if our path starts with a ick? Or what happens if our stack is empty, we try to pop something?
Those are great questions, and it's super important to think about those scenarios to make sure our algorithm is rock solid. So let's dig into some of those edge cases next and see how our stack-based solution holds up.
So we've really gone deep on this stack-based method. It's so elegant, so efficient, and like it just makes sense.
Yeah.
But are there any other ways to solve this problem? Or is this like the only way to do it?
Well, the stack is definitely a winner when it comes to clarity and how well it matches the way file systems are structured. But the cool thing about coding is there are usually multiple ways to get to the same result, right?
I love that, yeah. So what other approaches could we use here?
What if instead of using a stack, we work directly with the file path string? Manipulating it character by character.
So no more pushing and popping. We'd be like slicing and dicing the path string using string operations.
Exactly. It'd be like we're taking the path apart and putting it back together in a simplified form.
Okay, so we're getting rid of the stack.
Hmm.
But how would we actually simplify those components without the stack to keep track of everything?
We could have a variable to keep track of how deep we are in the directory structure. We can call it depth.
Okay, depth. So it's like a counter that tells us what level we're on.
Exactly. We start depth at 0 to represent the root directory.
Hmm.
And every time we hit a regular directory name, we increase depth by 1 because we've gone down a level.
Got it. And when we hit a depth, we decrease depth by 1, but only if depth is greater than 0.
Right, because we can't go below the root directory.
This is making sense. So we're essentially mimicking the stack's behavior using a variable instead of an actual stack data structure.
Exactly. It's all about finding different ways to represent the same logic. And, this approach has its advantages too.
Oh, yeah. Like what?
Well, for one, it generally uses less memory. With a stack, you need this extra data structure that can grow pretty big if you have a complex path. But with this method, we're just working with the path string itself and a single variable.
See, so if we're worried about memory usage, this string manipulation approach might be the way to go.
Right. It's all about trade-offs. The stack is really clear and elegant, but this way is more memory efficient. You choose what works best for you.
I love how exploring different approaches gives us so much insight. We've seen how to use a stack, and now we've seen this cool string manipulation technique. It's like we've got a whole toolbox of solutions now.
Exactly. And it all comes down to understanding the problem, breaking it down, and then finding the right tool for the job.
Well, this has been an awesome deep dive. We've learned so much about file path simplification, and I feel like I can tackle any messy path that comes my way now.
Me too. It's amazing how such a seemingly simple problem can lead to such interesting algorithmic discussions.
Totally. And to our listeners out there, thanks for joining us on this journey. We'll see you next time on AI.Code.Cast.